Hi, I'm Matthew Olage from the Anáhuac University at Querétaro. In this short video, I will introduce you to our paper Less is More, where we pursue the visual Turing test using the Kuleshov effect. The Turing test centers on the idea that if a computer could trick a human into believing that it was human, then the machine was deemed to be intelligent or indistinguishable from people. Until now, the proposed visual tests heavily used natural language processing to conduct the questionnaire or storytelling. We deviate from the mainstream, and we propose to reframe the visual Turing test through the Kuleshov effect to avoid written or spoken language. We hold to Kuleshov's viewpoint that cinema's essence is editing, juxtaposing one shot with another, and introducing the idea in computer vision that image understanding could be put to the test by attempting to recreate a mental phenomenon known as the Kuleshov effect in silico. First attempt to design a visual Turing test used binary questions to probe a system's ability to identify attributes and relationships in addition to recognizing objects. Other works use compositionality to describe complex scenarios. Additionally, in order to infer an image's communicative intents, various emotional traits have been integrated into top-down architectures. The reviewed literature exposes that current engineering trends demand new approaches based on psychology, physics, and symbolic learning to answer the question, can machines think? Following the imitation game. While the test is at the top of artificial intelligence, its reliance on language, whilst insightful for partially solving the problem, has put progress on the wrong foot, prescribing a top-down approach for building thinking machines. Instead of this path, we propose to avoid the problem of language, hence the top-down versus bottom-up dilemma, following the original pathway of cinema made during the silent film era by adapting the Kuleshov theory to the task of image understanding in computer vision. The test consists of simplifying the imitation game, since we first want to verify the capacity of current deep learning technologies. We juxtapose different concepts, like images of a city, money, fire, and so on, with a neutral face through artificial montage, resulting in an evoked facial expression not seen initially in any of the original elements. We use information collected by psychologists as ground truth from the open affective standardized image set, otherwise known as OASIs, where human beings respond to a wide variety of visual stimuli. Emotions are measured in OASIs using normative ratings on two affective dimensions, balance and arousal, which are used to abstract both the physical and social worlds on images. We implemented, trained, and tested a total of 40 frameworks, each using a combination between a CNN and an optimizer. During training, all convolutional neural networks were capable of reproducing with high fidelity the answers collected in the OASIS study as in the figure's first two rows. Despite the efforts to minimize overfitting, the high variability in concepts presented a challenge to achieve correct emotional classification during testing, as portrayed in rows 3 and 4. While human being reacts according to context and understands a presented scenario, architectures such as AlexNet react according to previously identified patterns. In this figure, we see how two images addressing the same theme, fire, can have two opposite emotional reactions. The same happens with similar cases showing cities, money, or couples. The proposed technique applies a test designed for humans to rate image content, and the results achieved with the computer reveals the difficulty of solving this task. In the future, we would like to test other deep learning approaches and take a step backward using a computer vision and computational intelligence methods, since we hold to the idea that less is more.